monitoring, and I personally love graphs. And the title of the talk, "It's not impressive unless it's monitored," is one of my favorite quotes, and so I thought I would actually dig and try and find out where it came from. And as best I can tell, Greg, I'm not even going to pretend to mangle his last name, not quite sure. But he's a DevOps engineer, an infrastructure engineer to have it at eBite. And it's kind of interesting, I think that he said this, because eBite is one of the old Web 1.0 properties, right? So it was launched in 1998. They sent something to the tune of over 1 billion invitations. And about the time he put this up on Twitter like a year and a half ago, they just finished completely overhauling their system, so moving from Java and Oracle RAC over to things like Python, Google App Engine, various Polyglot NoSQL solutions. And so it kind of made me start thinking about, so what about the context of that switch as you're preparing for the next decade, you made to say this? And so if you think about kind of how SaaS was developed, like 10 years ago, 14 years ago, you start, you get funded your quote-unquote seed round, it's the tune of millions of dollars. Now it's because to just even get going, right? You have big upfront capital expense, buy a lot of servers, physical rapid stack. You have a dedicated ops team, right? Who put those all together and finally write your own custom software stack, right? Google, the Yahoo's, where everything's in-house and everything runs on their own custom hardware. So now in 2012, right, we have your seed round. If you're not doing a seed round, not bootstrap, it's between $20,000. Your infrastructure is a monthly expense, just like your cable bill, right? If you're using Amazon or Rackspace or whatever. If you have an ops person, if you're lucky, it's one. Might even just be you. And finally, you're using open source software and external services to build your whole stack. So what this means is that our infrastructure now, what's interesting if you look at the two of those, our infrastructure now is what I like to think of as agile. Right? And definitely in the sense of agile, that moving quickly, adapting to change. It's ephemeral. Servers, instances come and go. You actually, when you talk with Amazon, they'll tell you literally, you have to use multiple availability zones because we reserve the right to take your servers away at any time. So we're now in an environment where we have more change, but we actually have worse tools, right? So Google has amazing tools for monitoring and understanding what's happening inside of Google, but that doesn't do you any good. And if you look, so we're now, because of this, we're kind of seeing a renaissance in monitoring, I like to think of it. If you look at companies, when you think of who are leading this, like the Etsy's, Flickr, or even GitHub, and I was trying to find a common thread of, what were driving these guys to be so heavy in monitoring for other people at the other end of the scale. And the one kind of common thread I came up with was continuous deployment, right? How many people here do continuous deployment? Right? Okay, so that's about half. That's good. I mean, a quick digression on that. One of the fascinating things I find about continuous deployment is it's easy to see the case where you say, oh yeah, we ship all the time, so we don't have this 3-month, huge release where there's all these features we ended up building that we didn't have to build and we waste all this time. But a lot of times you'll get these, someone come in and say, oh, okay, well, we'll be fine. We'll just schedule a release every week, right? Which sounds great at first, but it's kind of a false economy because if you ship once a week or once every 2 weeks, that means every week or every 2 weeks, you have a day where everyone's scrambling to do the big ship, right? They either trying to get code in time to make the ship, or they're trying to figure out why something's not working and the ship is being delayed. And so anything other than continuous deployment is really a trade-off between a scheduled waste of time versus wasting time on features that you may not need. So we do continuous deployment, and there's kind of, I like to think of 5 steps to do that. So first is continuous integration, right? So as developers, you run tests all the time, so you have the confidence, hey, I'm pushing the code out, but I know it didn't break anything. There are no regressions. I'm going to make deploying as cheap as possible. So one click, whether it's a campfire bot or a single button, make deploys as costless as possible. Once everything is out and you deploy, use feature flagging as an additional installation where you can kind of lead users on, your own users personally, and then a select percentage of users until everyone gets it. So this right here is a great setup already. The problem is even this, this is not enough. Bugs still make it through. And that's where monitoring comes in. And I think it's instructive. So continuous integration came out of Agile test-driven development, right? We have these tests where we run them all the time to reap the benefit. And if there's one takeaway, you should really start to think about monitoring and instrumentation is to operations as unit test is to development, right? If we have good monitoring in place, then our ops people will sleep better because they know I'll be able to tell instantaneously once this hits production that I don't have regressions. I can look at my dashboards and I can see there were no regressions. And the final component, so that's active monitoring if you're actually visualizing and you're checking right after the deploy, but there are latent bugs, you just have good alerting. And alerting is definitely a component of monitoring. So if something does happen 6 or 7 hours after deploy, you find out. As an example, here's a slide, yeah, it's kind of dark. But Travis CI, which is a great continuous integration project, did a post recently on monitoring, and this kind of illustrates the cycle that you go through. Where you start and you see the deploy, and they're tracking the number of error responses they get. So it's an immediate spike after the deploy. At which point I imagine they're scurrying around the keyboards trying to figure out what's going on, and they deploy the fix, and you can see that come back down. But there's still some noise, there's a green line noise. So they kept digging in, and you can see where they fixed another one. And at every stage, they had this immediate feedback on their progress in production. So that's a good illustration. I think that's a good driver. If that's not enough, I'm not sure how many hardcore reviews there are in here, but you can also find the chunky bacon using monitoring. This is actually a graph from the wild too. I'd like to say I came up with some algorithm to run that actually happened. So now that you know monitoring leads to bacon, so that's our first. If you need anything else, just think of it that way. Monitoring leads to bacon. You go to Google and you say, hey, I want to do monitoring. Let me do monitoring tools, and you get hit with this. It's an explosion, right? Of all these different services, tools you can use. Some of these, let's just try to put a mix up here. Some of these I personally think are really, really good. Some of these I think are not so really good. But my hope is that at the end of the talk, I'll leave as an exercise to the audience to be able to discern that for yourself. Now, if you do pick some of the not so really good ones, you're going to end up with something that looks like this. You'll come in and say, okay, well, I need to monitor this, and I did pick those names. That's not necessarily, that's a hint, maybe. You'll end up with a system where you say, okay, I want to monitor this one thing, or look on this one thing, I'll pull this off the shelf. It's got some agent, it's got storage, it's got a UI that you have to configure, and you're all set until you find something that doesn't do. So then you go to Google and you find another one that does that, you pull that off the shelf. And pretty soon you've got multiple vertically integrated silos, you can't correlate across them, and you have to learn how to use each of them. And at this point, you reach this stage. Where you say, you know what, monitoring sucks. It's really hard, there's huge tools with verbose configuration as code. They're designed for extremely long-lived physical hosts. They're trying to be a jack of all trades, they don't do anything well. And you invariably need more than one of them. And this is something else if you're interested in this stuff. Monitoring sucks is the Twitter hashtag. There's an IRC room, there's even a GitHub repository. And it's a whole movement of DevOps systems trying to make monitoring better. So we need a better model, and that's really kind of gets to the core of the talk. So I want to kind of build a model that you should think about when you're evaluating monitoring tools or building a monitoring solution, the things you should strive for. consider are the different metrics types we have. So you're going to be tracking your business drivers. It's probably a small number of things, but it's very important. It's the things that make you money. It's the things that keep you employed. So what are the numbers that if they go up or down, depending, improve your business? You're going to have your application performance. So generally speaking, this is how well your requests, how well is your app with your customers. That's going to be tied to your system resources that are used by the application, either memory leaks, so that's what's causing our application to slow down, is it disk full. And then it's network. Generally how I think, how many connection attempts we're receiving, what's the load balance we're doing. And what's interesting is you're going to want the ability to cut across all levels of the stack, right? If our business, for example, is driven by, you can think of it as the number of API calls we can handle. You know, we're a volume-based business. So we track very closely the number of API calls we're doing every second. And that is impacted by how many our application can handle, what type of system resources, and network. So we're going to use one of those monolithic things. So look at size. What does one of those monolithic things actually look like inside? Generally speaking, there's a collection stage, right? So this happens every request in your app. You have something happens, you measure it, now you have a measurement. And this happens in order 50, 100, 300 milliseconds, or one of Billy's web pages every 15 seconds. You get a lot of these. So for training, this information is way too dense, both for just visualizing as well as storing. So there's an aggregation phase where we roll up all these sub-second measurements into maybe 10-second interval or 15-second interval. And we have to get this to disk somehow. We have to store this somewhere. And then we have different types of analyses, whether it's just plain visualization, or alerting, or even some type of algorithmic mining. So as people who maintain and operate software platforms, this kind of diagram just starts screaming out at us when we're thinking about monolithic solutions, right? And this is a prime example of where we can use separations of concerns, right? We can split these behaviors out, and we can use well-defined interfaces between them, so we can mix and match what we want to do. So digging into some of those, the most important one, but this is the most important place to focus on probably is collection. Because if we're going to use monitoring for our operations, like we use tests for our development, then the cost of collection has to be as close to zero as possible. When monitoring sucks, nobody does it because it sucks and there's a lot of friction. So we need to make it super easy. You know, new code goes out, it should have instrumentation with it when it goes out, just like it has tests, and we have to make that cheap. The cheapest way to monitor something you already have is logging, right? And there's some cool projects you can use. Logs is one of them. If you think about logs as streams, right? There's a log file is interesting, semi-structured text, you have a big log file, and you can throw all kinds of weird queries at it, which is nice. But as it streams to that file, it's good to think of there are things in there. I can count the number of requests I had in 1 minute of that stream. Or I can count the number of 200, the number of 500. So there are several projects that will actually, as your log stream consumed, count things in them and generate statistics off them, which you can then graph, alert to all kinds of stuff. Logs is one. Logstash. These are all GitHub. Anywhere I have something slash something is GitHub URL. Logs. So Etsy gets those parts of your existing log files. Logstash actually mimics syslog and has storage engine with it. And then there's finally, there are a lot of good services too. We love Papertrail. That also looks like syslog and has integration with third-party services like ours for graphing. In Rails specifically, active support notifications. One of my colleagues gave a talk yesterday on this. You should definitely check the slides out. Basically, it's a pub sub instrumentation for Rails 3, which makes it really cheap. First of all, there's a ton of out-of-the-box instrumentation, and then it's really cheap to add new instrumentation to Rails apps. And you can pipe that stuff, publish it to multiple places. A couple cool projects. Matthias Meyer's LogRage uses this to trim your Rails logs, which will go well with anything on the previous slide. And then Harness is a neat thing to hook in, and then actually, instead of just going to logs, publish these to any third-party service. Another interesting collector for any Ruby project, although you can collect for that too, is metrics. And this is a project that just gives you simple primitives like counters, meters, timers, and it makes it really easy to plug in multiple reporting backends. It has Graphite, it has Ruscio support, it has Reunion support. So now you're collecting, we made it real cheap to collect. Some of those collectors, the metrics actually ones just on the last slide actually does aggregation, so there are some collectors. But if you're writing something custom, or if you're using one that does it, you don't have to worry about that. And so there are tools you can use. The most well-known one is StatC. That comes out of SC as well. They've done a lot of this stuff for monitoring. StatC is really interesting. It's about 319 lines in Node.js. It's a little daemon. It supports several different types, counters, time shaders. What's neat is it just sits on a port and listens for UDP packets, which means anything you're instrumenting, you have a zero cost, almost zero cost, to in the middle of your request response cycle, dump a UDP packet. It's just the memory copy to a kernel buffer, right? The way we get this set up, the way I like to think about it, you can't set one of these StatC names up somewhere in your network and you can't point all your servers at it. But given that it's like so small and so lightweight, we prefer to think of it as just something almost like a syslog, right? Where I just install it, runs on every one of this example of our front-end interfaces, and it just sits there. So if I bring any new service on this box, I know I have StatC locally. I don't have a single point of failure for aggregation in my network. And because the UDP is going over the loopback, I mean, training data, if you lose some measurements, it's not a big deal. I'm kind of pedantic. So I like knowing that it goes over the loopback and I have almost zero loss as long as the box is healthy. And besides UDP being zero cost, what's really neat about StatC is it's actually just defined in the UDP wire protocol. That's the most important thing it did. There are a ton of clients to that. Nginx module we use. GitHub put out a rack StatC, so you can get all those rack level statistics into it. Shopify has the StatC instrument, which lets you use in your application level and basically wrap code blocks and stuff and get things directly in StatC. And what's nice about doing it at multiple levels, the same kind of stats, is that when you're trying to debug a network issue and find out where your stack is coming from, you can compare these different ones. And because, like I said, it's just UDP wire protocol, if you don't want to run Node.js, that's fine. It's only 319 lines. This guy does joe.me. So on his blog, he maintains a comprehensive list, at least as recently as updated, with all these different StatC server implementations, Perl, Ruby, Go. So whatever language you're comfortable doing your production, managing your production, you can probably find an implementation of that. So now that we've got collection and aggregation, it's very cheap, low friction. The most important thing is how you collect all this data in a central location where you can access it and do any, your arbitrary correlations. And this is where I do think you want to think carefully here because collection and aggregation is streaming. It's very easy to swap things in and out. With open interfaces and having storage being its own component, that isn't as hard to swap in and out, but there is some persistence there. So the first RRD tool is the round robin database tool, and this is the default. I think it's like 10 or 12 years old. But most of these monolithic solutions actually use this internally, so cat powder in it. And what's nice about this, if you're not aware of it, it uses a circular buffer file to give you a constant guarantee of storage. So it writes new values into the buffer, and if you buffer enough space for 100 measurements, then 101 measurement will overwrite the first one. And it's designed for roll-up, so you actually get multiple circular buffers per metric, so you can have resolution. You can configure this, but you can do resolution of raw data, 10 second, 1 minute rollups, 15 minute rollups. So that was one of the first ones. I think probably what's more interesting is these next couple solutions. So Graphite is also based around RRD, but Graphite uses Whisper. This came out of Orbis in 2008, Orbis.com. One couple things to know, it's a flat hierarchical namespace, which means it stores just key values, but you can use your keys with dot decimal notation to add dimensions in the name as long as it's a proper hierarchy. And it supports to pull graphs out, PNGs, HTTP queries. A couple things to consider here. This does seem to be kind of the tool a lot of people use, and it's nice for that. But you do want to be careful to plan your capacity. This is generally used as a scale-up solution. It pre-allocates files for metrics. So I usually end up seeing, based on retention settings, people using about 3.2 megabytes per file. And if you end up with a lot of metrics, I have seen in production people running Graphite on a 64 gigabyte RAM FS. I've seen people with 10 SSD drives together in the RAID 0. Big hardware solutions to scale up to that. So if you think you're going to have that much data, one solution that's pretty neat came out of stumble upon is the open time series database. And that's based off of HBase2. And so what's neat about that, horizontally scalable, lots of storage. Supports, because it has multiple dimensions, so it uses denormalization. If you want to tag a particular measurement with multiple, I want to look this up on this dimension and this dimension, so I want to look this up on post name as well as the time zone. By writing the measurement multiple times and HTTP queries. And then on the outside here, you have to run a new query. Your last option is to use a service. We provide one. There are several others you can look for Google around. Typically, I think the best way to do this, what we do is JSON over HTTP. You just push the API measurements. There are additionally typically agents and language runs to make that easy. They generally have rollups and we have interactive frontends, typically services like ours. Visualization. There's a couple things to say about visualization. One of the most important is correlation. So you want the ability, and part of driving towards this common infrastructure, if collection is really cheap, and all these different collectors, you can come up with new collectors and get things in a central repository or Graphite open time series database. At this point, whenever you're trying to diagnose something, you have all the data in one place, you can build any graph you want, right? And in addition to putting metrics on that graph, ideally you're going to have a solution. One of the things we're working on and these existing solutions have is annotations. So an important thing to also think about events like deploys is something you should be monitoring, right? You should be pushing a stream, ideally with context of the shop of the deploy. So when you're doing correlation, you can overlay your deploys or overlay network events or whatever other events you're tracking right there. And you want these arbitrary combinations. A couple examples. This is open time series database correlation. It's hard to read legends. Came right off the front page, though. I think it's MySQL elite queries with 99th percentile performance. This is a correlation I took out of our system for our storage RAIN. And so it's correlating read requests into the RAIN. That's the orange, really periodic. So we have a periodic read activity with disk ops and IOPS and disk bytes read out of disk. So you can see those, always correlated with read requests. And at the right end of the graph, there's something much bigger that happened there. So it's probably a good idea that we have some other driver traffic that we want to look into. Those are the kind of things that's very, very simple correlations. Dashboards. So this is a bigger part of visualization. A lot of tools have correlation, but one of the things I think a lot fall down on that's hyper important are dashboards, right? And the reason for that, if you have dashboards, these are actually a way, much like you think as a wiki, to have a shared understanding across all levels of your team, right? There's a lot of times where someone asks you to go do something, go do this. The CEO said we need to do this. Well, why do we need to do that? And you don't know, you go do it. If you have your business drivers, or your app performance, or whatever, up on a wall on a platform where everybody can see when they're walking by to get their coffee, And everybody's on the same page. Not only that, everybody's on the same page up to the minute. And as you're doing that, also, there's no more sophisticated aberration detection than your marketing guy, who knows nothing about your technology looking at a dashboard, right? And one of the most interesting things is that that's literally happened to me. I'll be hacking away, and our marketing guy goes, "Oh, what is that? What is that?" And I'll look up and, oh crap, and then we have to go do something. And so it's really cool about having these all, having these up is people will see things. And finally, if your marketing guy is up at 1 a.m. looking at a dashboard when something goes wrong and your alert catches it, dashboards, if you have a dashboard for everything, this actually provides a firefighting manual, right? If your expert says, okay, I'm going to build a dashboard for this thing, these are the most important things for this. When something's wrong, go look here first. You're going to open it up, and something's going wrong, go open the dashboard for that. And you'll see, okay, this one looks really funny. So I'm not a total expert here, but this one I'm going to go first. So when you're looking at systems, and we focus a lot on this, but I think you want something that's going to make it very easy to template dashboards and make a lot of them, to make them easy to pull up. This example, like one of ours, this is for our API. So we track this one we have up. Our average response time, the response times for every post operation, response times for get operations, the number of errors and success codes we're returning broken out by host and stack track below. And so when any of these shift, we're dealing with thousands upon thousands of requests per second, things can get messy in a hurry. Dashboards should be a whole other talk. So this is a great book. It talks a lot about visualization techniques in general. Very easy to read, but also how to design dashboards and what to look for. So the last bit we're going to talk about is alerting. Oh, sorry, I had a question. Right. Yeah, so I think the question is, in summary, is if you're using something like a platform as a service where you don't have as much transparency into things, like if there's a load balancer on their part, how do you build a common dashboard that says, oh, it's not my service, it's theirs? So that's actually one of the hard platform as a service problems. And I think that space is maturing still. I think that's one of the things they're going to get to, but they actually need to give you access. Right now, using road as an example, right? They do provide road laws. So one of the things that won't help you in the case that the load balancer dropping packets. So using an external service like Kingdom or URL that's going to give you insight. So using that's one good thing about using specialized services is not necessarily bad. And everyone should obviously still use Google Analytics. If you have a lot of URL expertise, you're using that, you should be using that. I would look for services that give you the ability to pull out the through of the crop of what they're generating for you and get that into a common place you can correlate it against other things. So one thing I would look for is that with your Kingdom perhaps is an API that you can pull stats out and get that into common sourcing. So every minute you query your Kingdom, get the latest thing, and put that into the common canonical repository that's going to be driving your dashboard. We can talk about it if you want to. So alerts, the big thing with alerts is that you have to think of them as being alive, right? So if you set an alert up, something like this capacity is pretty easy to set a threshold and say, okay, when this thing gets 90% full and it's not magically going to get bigger, let me know, walk away, and touch again. But alerts for a lot of other things, as your service evolves, your thresholds are going to change. So you want to be thinking about ways that you can tune these. Right? Because there's nothing worse than a noisy alert. The first that annoys me, and the second I don't care about. You can, in my inbox is piling up with stuff, I just, that thing's always going. And something could actually be on fire. So templates for this ways I think about it. So you want where your threshold, this is what actually triggers it. That's simple enough. But look for things like having a cancel threshold. And part of this right now is some monkey see, monkey do. I'm still building this on what I'm building. But you're going to want something like a cancel threshold where you say, okay, when it goes over this, throw me an alert, but do not come to me again unless it goes down below this lower amount and then comes back up. Probably want to rearm window too. This is okay, we're going to have a cancel threshold, but if it does that within 5 minutes, don't bother me. You probably want some ability for a function on that. Say, I'm really looking for the exponential weighted moving average or min or the max. And you probably want to do that over several samples. So look for windowing capabilities too in your alert. And another thing for alerting is, I think, really look for integrations, especially in now is with third-party services, right? So when we do alerts, we just work on your stream, but then I think you want something that's going to say, hey, you can hook this in with your email, you can hook this in with your campfire, you can hook this in with your page review, and not say, oh, you better like our escalation strategy. You know, like myself, Martin, I don't know the first thing about escalation. So if you want escalation, go use page review. So whatever tools you have, look for integrations. And the last little thing, if I do, this next thing could be the subject of the whole talk, but this is still able to let learners paying attention. There are some very hard scenarios to deal with, right? We talk pattern behavior. So if your load is falling over time, right, and you have maybe some seasonal shifts, like Saturday nights my load is way less than Monday morning. How do you deal with that? And there's some interesting work being, I guess, done or has been done. I know we're looking into probably other people. How do you automatically detect that? And so one thing we look for is Holt Winters, which is a 50-year-old algorithm from the field of time series modeling. But the idea is that because this is all time series data, once I get past the collection point, it's all linear time series data, right? There are very advanced mathematical models. I mean, you guys on Wall Street make money based on time series data, so there's very advanced mathematical models for prediction. So if I apply one of these models to, say, my CPU load average coming in, I can predict, you could predict what the next value should be. If the next value shows up and it's some number of deviations away from that, it's something you should start looking at, right? Or maybe 3 in a row. This particular one is what's called triple exponential smoothing. And what's interesting about it is it takes 3 things into account. It takes a stationary trend into account. It takes a linear trend, so if traffic's growing from 8 in the morning to noon. And it takes a seasonal effect into account, which is, like any e-commerce site, December is way crazier than June probably. All right. So, in conclusion, a couple takeaways. When you're looking at tools, or building tools, and putting things together, try to achieve those separations of concern. Monitoring equals tests. For your ops guys, monitoring is your unit test. And for devs, you probably won't want to live without those, so make it easy for your ops and for yourself. You want the ability to have as much as you can a single repository that you